Alright guys, welcome to video number 2 for cumulative test number 5, and we're going to be starting here with number 12. Find the equation of a line in point slope form that is perpendicular to 6x plus y equals 12 and passes through negative 12, 7. So for this one, I know it says point slope form, but I'm going to go ahead and do point slope and slope intercept just for the sake of practice here. So first, we need an equation that is perpendicular to this line. Now this one again is in standard form. So what I need to do first is move the 6x to the other side so I can clearly see the slope. And luckily for us, the y is already alone. So my equation would be y equals negative 6x plus 12. So it seems like the current slope of my line is negative 6 or negative 6 over 1. But if I want a new line that is perpendicular to this one, my perpendicular slope is going to be opposite reciprocal. So I'm going to take my negative 6 over 1, I'm going to change it to a positive 1 over 6. So that's not plus 1/6, I just did that to show you that the slope should be positive. So now I'm going to be using this slope, and I'm going to be using this point to find a new equation that is perpendicular to this one. So if I plug into the point slope form, I would get y minus 7 equals 1/6 x minus negative 12. Y minus 7 equals 1/6 times x plus 12 technically. So I am going to box this because originally I did ask for it in point slope. So if this were the test, your answer would be done here. But for the sake of practice, I'm going to keep going to slope-intercept form as well. And to do that, if I distribute, I get y minus 7 equals 1/6 x plus, this is originally 12 over 6. Now, some of you probably already knew that was going to be 2, but I just like to show my work. The last thing I need to do is add the 7 to both sides. So my answer in slope-intercept would be y equals 1/6 x plus 9. (13) and 14 are asking you to graph these two lines in whichever way you see fit. If you like the just graphing with y equals mx plus b, you could do it for both of them if you'd like. If you like a table, that's great. If you like the x and y intercepts or the cover-up method, that's great as well. I'm going to choose here to use the way that I think is fastest, but you are welcome to do any method you'd like. For 13, I would say that the method that is the quickest is to recognize that your slope is negative 1/3, which means you are going down 1, right 3, and your graph would start at the y-intercept of 0, 5. So on a test, what I would do is go up to 0, 5, and then I would go down 1 over 1, 2, 3, as many times as you need. Down 1, 1, 2, 3. Remember that if you put the negative on the 3 instead, you could also go up 1, left 3, which I'll do now. You go up 1, left 1, 2, 3, up 1, left 1, 2, 3. Notice that it's still in a line, so if we connect all of these dots to the best of our ability, this would be the equation of the line. Now I do just want to point out to you that if you're a big fan of the cover-up method, you could multiply this entire equation by 3 and get it in standard form, like 14, and you can graph with the cover-up if you want. Number 14, I am going to use x and y intercepts, aka the cover-up method, because it is the fastest because it's in standard form initially. So if I want to find my x-intercept, that means that y is 0, because any y value along this line is 0. So if I plug in 0 here, it's really covered up. So I'm left with just 2x equals 21. If I solve this mini equation, I get x is 10.5. But as a coordinate, that is 10.5, comma, 0. So it's going to be a little bit off my graph. Here's 10, so I'm going to use a different color. 10.5 is probably right about here. If I would like to find my y-intercept, that means that x is 0, because all along the y-axis, x is always a value of 0. So if I plug 0 in for x, what's left is just negative 7y equals 21. And if I divide both sides by -7, I get y equals -3. But as a coordinate, that would be 0, -3, which would be here. So if I have one dot here and one dot here, if you connected those two, that would be the equation of your line. If you prefer the first way that was graphed over here with the slope and the y-intercept, feel free to take this equation, solve it for y, get it into this form, and graph like that. Now that you know multiple forms, you have many choices in how you want to graph a line. Number 15, find the x and y intercepts in the following graph. Describe what the intercepts mean in terms of the situation. Now, on the one other test this was on, I noticed that some of you just explained what an x and a y intercept is and where it hits the x and y axis. What I'm looking for is the description based on this situation here. But first, my x-intercept is where it crosses the x-axis, which looks like at 15, 0, versus the y-intercept is where it crosses the y-axis, and that looks like right in the middle of 20 and 30, so 0, 25. I'll write this a little bit more neatly here. 15, 0. So in this circumstance, we are dealing with a distance of a jet from an airport, and the y represents the height in miles before the descent, and the time x is in minutes. So if I have an x-intercept at 15, that means that my time is 15 minutes, and my height is 0. So if I describe in words what this means is after the jet starts to descend to the airport, it takes 15 minutes to land. Something along those lines. After the jet starts to descend to the airport, it takes 15 minutes to land or to hit the ground. If I want to describe my y-intercept here, this time my height is 25 and my time in minutes is 0. So this means that you're dealing at the start or before you descend. So you could say something like, before the plane starts its descent, to the airport, plane or jet, similar, it is 25 miles away. So the x-intercept means after the jet starts to descend, it's going to land on the ground after 15 minutes. The y-intercept means that at the start or before you descend, the plane is 25 miles from the airport. In 1955, the population of a town was 11,000 people. In 2015, the population grew to 21,500 people. Find the rate of change from 1950 to 2010. Rate of change, anytime you see the word rate, should mean slope. So what this question is asking as a review is just what is the slope of the situation and what does it mean with units. So to find a slope, I first need to find 2 points so I could find the slope. And I have the 2 points in the situation. In the year 1955, there were 11,000 people in the town. In 2015, the population grew to 21,500. So if I want to find my slope, I take y2 minus y1 over x2 minus x1. And if I do that, the top ends up being 10,500 if I subtract them, and the denominator ends up being 60. If I divide 10,500 divided by 60, I get a very nice answer of exactly 175. But leaving 175 isn't enough because it's a word problem. we're dealing with population per year. So this answer would be 175 people per year. And if we want to be even more specific, you would say the growth is 175 people per year. Number 17, 5 less than the quotient of a number in 3 is at most 35. So first, quotient means the answer to a division problem. So the quotient of a number in 3, I'm going to write as a fraction, as the number divided by 3. Now we have 5 less than that quotient. So the 5 you are going to subtract from the quotient, and this is at most 35, which at most to me means that the biggest it could possibly be is 35. So it has to be less than or equal to 35. So this is the answer to your inequality. If I continued to solve it, I would move the unattached 5 first. So I'd get x over 3 is less than or equal to 40. Then if I multiply both sides by 3, the number I'm multiplying is positive, not negative, so the inequality does not flip. So my answer will be x is less than or equal to 120. Solve the following equation. All right, looks like some distributive property to start, so let's simplify both sides. On this side of the equation, we have a single distributive property. So that would be negative 10x, negative times negative, plus 35, plus 13x. So we simplified that side a bit. On this side, we have a distributive property, and please notice that what's being distributed is not the 20, it's just the negative 3. So the 20 stays where it is. We distribute the negative 3 to be negative 3x plus 15, because the double negative, because remember a subtraction sign and a negative are interchangeable, plus 6x. If I combine like terms on this side, negative 10 plus 13x is 3x plus 35 over here. Then on this side of the equation, if I combine like terms, a negative 3x plus 6x is again a positive 3x, and the 20 and the 15 is also a 35. Interesting. 3x plus 35 equals 3x plus 35. I'm thinking the answer is all real solutions, but let me just make sure. If I subtract my 3x's, they cross out. So I'm left with the statement 35 equals 35. This statement is always true, which means yes, my answer is all real numbers, or all real solutions. I will take either of these. I will also take that symbol with the big capital R. Any of these are acceptable. This means that no matter what value I plug in for x, these two sides of the equation will always be equal. The last problem for this video is number 19. Evaluate or simplify using the order of operations. So we want to evaluate this given that x is negative 4. So anytime I see every time I see an x value, I'm going to plug in negative 4 instead. And I'm just going to be careful and use parentheses just to make sure I don't miss anything. So I plugged in negative 4 here and here. Now the order of operations says that I must take care of parentheses and I must take care of exponents first. I see parentheses and exponents. So that 3 we're not going to touch yet. But negative 4 squared is negative 4 times negative 4, which is a positive 16. Plus 5 times negative 4 is negative 20. Multiplication always comes before addition or subtraction. So 3 times 16 is 48. 48 plus a negative 20 is a positive 28. All right, guys, this is where this video ends. Please join me for video number 3 to finish up this review packet.